Okay, we're going to go through page 15 now. Now this is all about terminating and recurring decimals. So a terminating decimal is one which stops. For example, 0.3. Okay, that would be a terminating decimal. Terminate means to stop, so it just stops and there's no more digits after that. So it is a decimal with a finite number of digits. And that word finite is the opposite of infinite. Okay, so it means it just has a set number of digits. A recurring decimal is a decimal with an infinite number of digits. And it also has a recurring pattern. Now that pattern might just be a single digit repeating itself over and over. It might be 2 digits repeating themselves, or it might be lots of digits until that pattern repeats itself. But it has to have a repeating pattern for it to be recurring. Okay, there are some decimals that just go on forever but have no repeating pattern in them, but we'll come to those later. The numerator is the top number in a fraction. And the denominator is the bottom number in a fraction. These definitions are a little bit better worded in the glossary at the end of your pack. Okay, I'm going to show you how to turn fractions into decimals and figure out whether they're terminating or recurring. So half, to do what that fraction is actually saying, this is saying 1 divided into 2. That's literally where half comes from. Okay, so that's the division we're going to do. We're going to do 1 divided by 2. Okay, so 1 goes inside the bus stop, 2 goes outside. Now I know this isn't going to divide because I know 2 is already bigger than 1. So I'm just going to turn this into 1.0. Okay, I've not changed it, it's still the same as 1, but I've just written it as 1.0. And because I've put a decimal point in, I'm going to put 1 on the answer line above as well. So how many 2's go into 1? Well, 2 is too big to go into 1, we said that a minute ago. So normally what we'd do then is put the remainder, whatever's not been used from this digit, up here, and we can still do that. But we can only do that now that we've added this 0.0. If we hadn't have done that, there wouldn't be anything to put this 1 next to. How many 2's go into 10? 5. Okay, so you can see that half is 0.5. And is it terminating or recurring? Well, it terminates, it stops, so it's terminating. Okay, 1/3. So we're going to do 1 divided by 3. I'm going to add 0.0 here. Okay, how many 3's go into 1? None of them. That means the 1 goes there. How many 3's are going to 10? 3 3's would make 9. So there'd be 1 remaining. And we would just keep adding zeros if we need it. How many 3's go into 10? 3 with 1 remaining. How many 3's go into 10? 3 with 1 remaining. And so on. You can see this is just going to keep going, and therefore so will the answer. Okay, so our answer is 0.33333 forever. And the way we can write that as a recurring decimal is to put a little dot above the 3. Okay, try not to use an R or anything. You might get mixed up with remainders. Some people still use those. So this one is recurring. Okay, a quarter. 1 divided into 4. I'm going to change it to 1.0. That's my point there. How many 4's go into 1? 0. How many 4's go into 10? 2. 2 4's make 8, and I've got 2 remaining. So I'll put that next to a 0. How many 4's go into 20? 5. And then it stops there, no remainders. So 0.25 and it is terminating. Okay, 1/5. That's 1 divided by 5. I'm going to make it 1.0. How many 5s go into 1? None. How many 5s go into 10? 2. So this is 0.2 and therefore terminating again. I'm not saying this is the best method of converting fractions to decimals. Personally, I would just make that into an equivalent fraction like 2/10, and then you've got your decimal straight away, 2 in the tenths column. Okay, but it is the fallback method. If you can't think of how to scale something up, just do the division. Just use the bus stop method. Okay. 1/6. So 1 divided by 6. I'm going to put a 0.0. So there's no 6's going to 1. So we've got 10 now. How many 6's going to 10? 1, with 4 remaining. How many 6's going to 40? 6 6's are 36. So 36 to 40, that leaves 4 remaining. How many 6's going to 40? That's 6, 4 remaining, and so on. We're going to keep getting this. Okay, so we're going to keep getting a 6. Slightly different to the one above, though. We just had 3's. Here we have this 1 at the start. Okay, so the answer is 0.16, and it's just the 6 which recurs. So just put a dot above the 6, not above the 1 as well, just the 6. So that is a recurring decimal. Okay, 1/7. 1 divided by 7. Now I know from past experience this is quite a long one. Okay, but just keep going with it. So make it 1.0 first. How many 7's going to 1? None. 1 goes there. How many 7's going to 10? 1, with 3 remaining. How many 7's going to 30? Well, 4 7's are 28. So we've got 2 remaining. 7's into 20, 2 7's make 14. 6 remaining. 7's into 60, so 8 7's are 56, so we've got 4 remaining. 7's into 40, 5 7's are 35, which leaves 5 remaining. 7's into 50, 7 7's are 49, and then we get a 1, should give us 7's into 10 again. Now we've already done 7's into 10 here, so we're going to get 1. We're going to get a remainder of 3, and so on. And so therefore this pattern of 6 digits, okay, so I'll just put the 1 there anyway, just so you can see, and that would be a 3 and so on. Okay, this pattern of 6 digits from the 1 to the 7 is going to repeat. Okay, so it would be 0.142857142857 forever. Okay, so the way we show these with recurring notation is to put a dot above the start of the pattern and the end of the pattern. Okay, so this is recurring as well. And finally 1/8, so 1 divided by 8. How many 8's go into 1? 0. 1 there. How many 8's go into 10? 1, with 2 remaining. How many 8's go into 20? 2 8's are 16, 4 remaining. How many 8's go into 40? 5, and it stops there. So 0.125, so therefore 1/8 is a terminating decimal. Okay, thanks for watching. The next video will cover the next page.